Alright, I figure it's about time I actually did an update. Because, believe it or not, I actually have... done a lot since the last time. Admittedly, I'm not working on... Yeah, I put this project down for a moment because it was working with tutorial, and maybe I'm considering going back to this. You gotta at least finish off, you gotta at least finish off your tutorials before you start something new. That being said, I started something new. Yeah, I'm well aware. I'm well aware. I'm kind of getting too ahead of myself. You gotta learn to walk before you run. And right now I'm trying to run before I walk. You know what they say. You say got that you say run energy just going through me. So I guess I'll just quickly run through this what new stuff I've been working on. Just just an explanation. A lot of this is not actually my own work. I've had quite a lot of help. Obviously, once again, brackies. A lot of progress that you end up making it because having a person there right next to you is such a benefit. Now, one of the major skills that I actually have learned is understanding how to utilize this add-on for Unity called Pro Builder. As you can tell, these two obstacles are they're very different, aren't they? But the basic premise is that this obstacle is just made with a bunch of cubes, just kind of slapped together. It's like the first map I ever made. This obstacle was made with actual Pro Builder, and as you can see, it's a singular piece with extruded parts, just like a basic modeling program. Now, as you can see here, why are the block boxes and kill boxes? Anyway, as you can see here, the way this game works is actually based on what's called an infinite runner style game. Meaning that your character that within the logic or the context of the game's quote unquote plot, your character is constantly running. So the idea is that these obstacles are going to be moving towards you, or ra- rather, you are moving toward the objects. So I'm going to start the simulation, and let's just hope. Yeah. So as you can see, the obstacles are moving towards you. You can also move as well as increase the speed by which the object goes towards you. The way it works is that the majority of the objects in this game will be running what's called the static speed script. The static speed script essentially takes the speed value of the player character, which is actually the back and forth. This actually controls the lanes here. This is because of how the player character is set up. You see, the player character's script, which is up here, the left right 2, which is called the left right 2 script, is that it actually absorbs the elements of the various lane. It actually absorbs the information from every lane. So if I were to go here, and I'll show you very quickly the left right 2 script. Now a lot of this is from a fella named Unbreakable. Really nice guy. Met him at the Bracky server once again. If you are having difficulty, a lot of it really helps to have somebody just be there and just be there and help work with you. But the way they've set it up is that there is is the utilization of indexes, and from there, you absorb these objects, which is the number of lanes, and you can actually. The way he set it up is that you can actually increase the number of lanes that are in the game. So if you recall here, oh wait, no. If we recall here, the size is 7. This means that it is able to take in 7 lanes. 7 objects that would qualify that would be part of the index. From now, I'll tell you the part that I did help with, and a lot of it is just tweaking on top of it. Things like for example, the left checked and right check. The way left and right check works is that they are actually objects. They are empty game objects that only exist to produce what's called a um. Wait a moment. A radius. Move to. Get key down. Fix update. I'm sorry. Yes. The only purpose of them is to generate what's called a check sphere. The check sphere will simply exist, and anything that runs into it, and if it has the layer mask of what's identified as an obstacle. So if you come down here and you will see the left check and right check. They are actual game objects that have been bound to the script here. And the obstacle layer mask is of course obstacle. This will read the layer of the object here. And this is actually why creating obstacles is actually quite a bit harder than one would typically think. Because the way it works is that the game needs to identify 2 parts of the obstacle. One is the actual blocking aspect. So I'm going to start the game again, and I'm going to simply show here. Oh wait. Oh. Okay, sorry. Yes, as you can see here, because my player character is next to a wall, and if we take a look at the obstacle 2 here, if you take a very close look on the inside of there's actually a very small box, and I'll show you block boxes. It's right here. Oh yeah, it's right here. That is so what this block box does is that these block boxes have the layer mask of obstacle. Because of that, will trigger the player's left block, because the invisible game the empty game object, which is the left block on the player. If we go back to it, wait, where's the left right check? Oh yeah, left checked. So as you can see here, the left check object is checking that the block object in this obstacle. And so the way it works is that because that check exists, it will then trigger. If those checks exist, then it will create. Yes, if physics Reika. Wait a moment. No, that's not right. Oh yeah, here it is. Obstacle check. Mm, So pretty much what this says is if anything impacts these the check spheres that have been generated by the obstacle and match the obstacle layer mask, it will what it will do is that it will tick left block. It, it will make the private bool, which is a boolean, which what a boolean is a simple yes or no pro. A boolean is a simple yes or no program. It's something is either true or it's false, much like in real life. I'm kidding. But essentially, when an obstacle when an object with the layer mask obstacle collides with the left block check sphere, it will make the left block boolean equal to true. The way this is set up is that if you get key code is that if you press A or D, it will it will increase or decrease the number which is known as the index. The index therefore identifies what lane you are sitting on. Sans the limit as well. So the way it works, so essentially, if each obstacle, each lane, I'm sorry. So if you go back to the player, each lane corresponds to a number on the index. So essentially, if my index is 2, if my index is 3, I will be on the lane which is element 3, which is going to be the central lane. You're probably wondering why that is. That's because we're including 0 as a value. So for example, central element 0 is central lane 1. Central lane 1 is here. Element 1 is central lane 2. Element 2 is central lane 3, and element 3 is central lane 4. Sorry, I got mixed up. So the thing is, if it is element 3, it will be on central lane 4, which is this central lane over here. It is a very middle lane. So imagine it like this. Each lane has a number corresponding to it. 0, 1, 2, 3, 4, 5, 6. As you press the A and D button, the value that tells the game that your character is supposed to match the transform location of the corresponding lane. So yeah, which is why you need to absorb all of these game objects. These lanes all need to be their own separate game object. Alright. Now, there's also a few other things. For example, you notice how when I play the game, my pistol is actually able to move. This is actually a very recent development, which actually came with help from a very different developer. Oh, sorry. The kill wall, while set up, it will not activate within the test function of the game. Essentially, it will not destroy the game. The kill function doesn't destroy the game object. It simply resets the level, and that's what player death actually does in a lot of games. But simply put, that is its own thing. As for what I meant when I said that forward and backward movement is actually on the lane itself, is that because the way the player functions if the player's back and forth mode, all the player's entire location is based on the location of the lanes, which means it will always sit in the middle of the lane, because that is the it's taking the transform information up here, transform.position information up here, and applying it to the player. So what's actually happening is that when you are moving the player character forward and backward, it's actually programmed that the lanes themselves are moving backwards and forward. And since the player character is designed to follow the location of the lane, he will therefore go back and forth. Everything else is just kind of everything else is actually a strict location A to location B movement. The obstacles movement system is simply it's here. It simply grabs the start position, which is 400 F in the x-axis, 400 hit at negative 400x on the x-axis, and it's just going to say you're going to start here and you're going to move to here. When you move here, hide, which will be the hide position, which is negative 400 on the y-axis, which means it's going to hide underneath the game. This is how the whole concept works. As for why there's a gun, this is supposed to be a combination of an infinite runner plus rail shooter. So a few things that I need to do is set up a spawn manager for obstacles, then set up a spawn manager for enemies. Well, I need to set up the enemies and then make a spawn manager for the enemies. Then after that, now that we have the gun following the location of this, to explain how the aiming system works. The basic idea is that you create a game object, this game object over here, and then on your hand you have what's called a look at constraint. A look at constraint will then absorb. You essentially apply the object here, this little game object, which is just a sphere named aim point. You can name it whatever it is, and it's just a simple game object. It could be anything, but it just needs to be a game object that exists. But then what you do is that you have the hand, and you apply it onto the aim, and you apply it to the aim point. You apply the game object here onto here, and the basic premise is that as it moves, it will actually change the location of the gun. Now, that I did not show that very well, I'll be honest. Oh dear. Oh dear. Just a moment, I gotta fix this. Oh dear, oh dear, oh dear. Well, it really doesn't matter because when the game actually starts, the aim point will always be it's programmed to follow the location of your mouse. That sounds simple, but truth be told, this sounds simple, but truth be told, it's actually a bit more complicated, because the thing is this is a 3D environment. If you are aiming here, you are essentially aiming all the way up into a potentially infinite distance. The truth is that's not actually true. That's not actually the truth. You can't see it right now, but there's actually an invisible plane here. The invisible plane will more or less judge where the will simply be the absolute limit as to where the aim point is going to hit. The aim point constraint. And we're going to quickly go to the player, and this links to what's called the player aim script. This is an entire thing where it's just going to be focused on where the script goes. And I think a major problem here is that I parented the game object aim point to I parented the game to the game point object. But yeah, this is the thing I'm talking about. Essentially, wherever this object is, wherever this little aim point is the gun will always follow it because it is programmed to look at the it's always programmed to look at the object. So I just need to, there it is. As you can see here, the pistol is absolutely always going to be pointing at this game object. That's okay. Dear Lord. Needless to say, this is a lot of complicated stuff very quickly. There's a reason why I needed help with this. But let's just take a quick look at the actual, because to make this the aim point actually follow your mouse, that is the purpose of the player aiming script. So, what does the player aiming script do? Well, and also it's on a separate game object. You're probably wondering why they're on separate game objects, and the simple thing is that we don't want to clutter the central game object. We don't want to put too much clutter on one script. This is kind of the same major problem that Yandere Dev did. He essentially tried to put too much function of one script in of every function of the game into one script. You don't want to do this. So essentially, so what are we going to do? We're going to have, so it's the player aiming script is going to take two objects. It's going to access the main camera and the aim point. So these two become parts. These two become an important. These two become linked to the script more or less. Now default. So next up, we're going to talk about, and it also needs a layer mask. This will dictate what the game will qualify as an object that the script will apply to. I'm not sure if that makes sense, but just bear with me. I'll try to explain as much as I can. So, what do we do here? So if cursor.visible equals false, void update, and what this script, and this is, you'd think a lot of what was happening back there would be a lot longer than this, right? Well, no. What this is that it's generating a raycast based on the camera and screen point to ray. So it will. So what this does is that it identifies your mouse position based on your camera. So your camera will identify where the mouse is and the mouse position within the camera. Because technically the mouse cannot exist outside the camera. The how should I say this? The mouse is not an actual object. It just identifies where your mouse is on the screen. So to get access to this, you need to have screen point to ray. what this does is that it ensures that your screen, or at least the game object, will identify where your mouse position is relative to the screen and will then take that information. If the raycast registers a hit, so if this and this will it will generate a raycast that will try to hit the location of your mouse. If it hits, it hits. If the raycast out is hit out to a maximum range here, there's a reason why it's 1000. 1000 dictates the maximum range by which the raycast will track up onto. Because technically, if the mouse is going out to forever, if the mouse is here, remember what I said about an infinite location. You're pointing out to an infinite distance. That is why we have our plane here. Why we have our invisible plane here. The purpose of this is so that the raycast will identify it will project a raycast up to a certain distance and will try to identify the mouse's location from the screen, as well as if it has collided with an object, or at least tries to gauge what your mouse is pointing at. I'm sorry. I'll admit, I'm still a newbie at this. This is just as new to me as it is for most of you. You can tell by just how much difficulty I'm having trying to explain this. It's a lot of very complicated code. I had a lot of help with this. Perhaps one day I can, and I hope to one day look at this and maybe to maybe learn enough and gain enough skill. The reason why, so you're probably wondering why if this transform is 400 location 400 away, or at least, yeah, the X position is 400 away. Why did I choose 1000? That's to account for angles. Because the thing is, if you're out here and you're drawing a ray, and let's say your mouse is pointing all the way out here, that is a line that's being drawn from here all the way out here. Suddenly, the distance is no longer 400. It can be, well, that's for geometry. That's for more geometry-minded folks to figure out. But as you can tell, the distance is much further. It's much further to gauge the distance between here and here than the distance between here and here, just by the line, just identifying by how far the line would travel. So the distance of 1000 is specifically there to ensure that no matter what happens, your aim will not just fail to register, because it will only register if the ray hits an object. See what I mean? It's oh man, it is a lot of very complicated code, and some of it that's kind of it's kind of the whole learning experience. You need to keep diving in, keep learning, and keep having that attitude to just keep going even when you feel like you don't understand it. Because the thing is, if you give up, you'll never make it. I don't want to be that mean, but you think of it as encouragement. Even if you don't get it right away, you will eventually get it. It's a matter of how fast you can learn, and how quickly you can do it, or whatever. I'm sorry. I am trying to be concise. It's just I'm not very good at it. Anyway, that's really all I have to show. Aside from this project, which I've already shown you everything, and I'm probably will be going back to this project now that I think about it. I don't feel good about leaving something halfway done because I have a bit of a history of not finishing things, and I'm sick of it. So I guess I'm just gonna go. Once I'm done recording this video, I'm gonna get back on the horse. I've actually been really busy in my life recently. I haven't been able to work on projects as often as I wanted to. So, and yeah, I understand this is still technically a hobby. It's still a hobby for me. You take it one step at a time. Anyway, um, that's me, Epsilon Core. I hope you all have a nice day, and I'll see you later. Cheers.